Hello everyone and welcome to STEM School. Now in this one video, I'll explain everything you need to know about the trigonometry of right angled triangles. I'll explain the concept and formulas quickly and then move on to some typical exam questions so you're best prepared for the exam just by watching this one tutorial. So before I begin, please do remember to hit the like button and consider subscribing to the channel. That'll be fantastic. Alright, let's get started. So whenever you see a diagram of a right angled triangle just like this, you should immediately think of Pythagoras or trigonometry. So for trigonometry, there are three formulas you can use to work out the lengths and the angles of the triangle. So if you look at this right angled triangle over here, what we have here is the right angle symbol there, and then this angle here, x, okay? So what you should firstly be able to do is look at the right angle triangle and label each side of the triangle depending where the angle is, okay? So the scenario is, when you're in an exam, you'll be shown a diagram of a right angle triangle. So you need to label each side correctly. So first things first, the side that's opposite the angle here, x, well that's something called the opposite, okay? The opposite. Then the side that's opposite the right angle symbol, well that's something called the hypotenuse, okay? So you should be aware of the hypotenuse. It's always the longest side of the triangle opposite the right angle. Then the last side of the triangle is something called the adjacent, okay? So that's how you label the sides of the triangle correctly. Now there are three formulas you need to remember. So basically you'll be shown a right angle triangle and you might be asked to figure out one of the lengths of the sides of the triangle, or you might be asked to find a missing angle of the triangle, okay? So these are the three equations that you can use, the three formulas. So what we have here is the sine equation, then we have the cos equation, and then the tan equation. So first of all, sin x is equal to opposite over hypotenuse. Then the cos equation is cos x is equal to adjacent all over hypotenuse. And then the tan equation is tan x is equal to the opposite over adjacent. Okay, so these are just three three formulas you need to memorize. So when you're actually working through these equations, what you need to do is be able to rearrange these equations correctly. So if you want to, for example, get rid of sine, or if you want to get rid of cos, or you want to get rid of tan from the left-hand side of the equation, you need to basically take the inverse of it, okay? Just leaving you with the x on the left-hand side. So for example, for the sine equation, if you take inverse sine both sides, this is how you write it. You do sine, then -1, and then of the fraction of opposite over hypotenuse. And it's similar for the cos equation. You take inverse cos and then you take inverse tan, okay? So yeah, those are the three formulas that you need to remember for this topic. And another wee fact that you need to remember is that in a triangle, the angles in the triangle add up to 180 degrees, okay? 180 degrees. So when you have a right angle triangle, obviously the angles still add up to 180 degrees, but you still know at least one of the angles is 90 degrees. So basically, if you know two angles of the right angle triangle, then you'll be able to figure out the last angle here, okay? So that's basically the principle and the concept of trigonometry of right angle triangles. So what we'll do next is do some exam questions, and you can see how to use something called SOH CAH TOA, okay? SOH CAH TOA, which is spelled like this. So SOH CAH TOA stands for sine, cos, and tan. So in the questions, I will show you how to use SOH CAH TOA, and then that's basically telling you when you get given a question on a trigonometry of right angle triangles, using SOH CAH TOA will tell you which of these three formulas you need to use to solve that particular questions. So we'll have a go at those questions next. Alright, so let's dive into some exam questions then. Now if you look at this diagram here, what we have is a right angle triangle. So immediately you should think of, Pythagoras or trigonometry, right? But in this case, what we are given is an angle. We actually have to find the angle in this case. So that should imply we need to use trigonometry. So these equations up here should immediately come to your head. So how do we approach trigonometry questions? Well, luckily the method actually does remain the same. So what you want to do is, first of all, label the sides opposite, adjacent and hypotenuse. Now after that, what you want to do is write SOH CAH TOA down and identify the sides that have been given to you in the question, and also what you're trying to find. And that will tell you which of these three equations you will need to use to figure out whatever you're trying to figure out. So in this case, we're trying to figure out the angle. So let's have a go at that. So the side that's opposite the angle is the opposite, right? And then the side opposite the right angle is always going to be the hypotenuse. It's the longest side of the triangle. Then the last side of the triangle is the adjacent, just like that. Okay, so that's how you correctly label each side of the triangle. Now the next step is to write SOH CAH TOA down, just like this. And then what we know is this stands for sine, then we have cos, then we have tan, right? Now we want to identify which sides have been given to us in the question and what we're trying to find, right? So in this case, we've been told the length of the opposite, so then we tick off O, just like that. Then we are also told the length of the adjacent, 7 centimeters, so we can tick off A. Alright, now after you've done this, now the one that has the most number of ticks, well, that's going to be the equation that we use. So in this case, we have to use the tan equation, right? So let's write that down. So tan x is equal to opposite over adjacent, right? Then all we have to do is just substitute the values in. So we have tan x is equal to, so what is the opposite? So we're told it's 3 centimeters. Then adjacent is 7 centimeters. So now what you want to know is how to rearrange this equation correctly. So to get the angle by itself on the left hand side, what you want to do is take inverse tan. Okay, so this is how you write inverse tan. It's tan with a -1 of this fraction here. Okay, 3 over 7. Now if you just pop that into a calculator, inverse tan of 3 over 7, we get the final answer of x is equal to 23.2 degrees. And that's how we figure out the question, okay? So you just have to follow this process of labeling the sides and using SOH CAH TOA to identify the correct equation we need to use, alright? So that's pretty easy to understand, right? So what we'll do is have a go at this second question then, so you can easily understand it for sure. So again, we have a right angle triangle and we've been shown an angle on the diagram. So that implies we need to use trigonometry. Alright, so how do we tackle this question? Let's label each side of the triangle as opposite, adjacent and hypotenuse. So the side opposite the angle, that is going to be the opposite. Then the side that's opposite the right angle, that's always going to be the hypotenuse. Then the last side is going to be the adjacent, okay? Now the second step is to use SOH CAH TOA, and that will help us identify which of the equations we need to use. Okay, so sine, then cos, then tan, just like that. Now we just tick off the sides of the triangle that we've been given and also what we're trying to find. Okay, so if we look at this diagram, we've been told the adjacent is 9 centimeters, so we can tick off A, just like that. And we've been also told the length of the hypotenuse, which is 10 centimeters, so we can tick off H. Okay. Now the one that has the most ticks, that's the equation we're going to use. So we're going to have to use the cos equation. Okay, so what is the cos equation? So the cos equation is cos x is equal to adjacent all over the hypotenuse. Okay, so this is a new equation that we need to use. So all we have to do is just substitute the values that we know. So we don't know the angle, so it will just be cos x, just like that. Now what's adjacent? So we're told it's 9 centimeters, then the hypotenuse is 10 centimeters. Okay, doke. Now what we want to do is rearrange this to get the angle by itself on the left hand side. So in that case, what we want to do is take the inverse cos. So it'll be cos, then -1 of the fraction, cos -1 of 9 over 10. Okay, so when you pop that into a calculator, the final answer will be 25.84 degrees, just like that. So as you can see, it's the same process as before, right? Alright, so we'll have a go at this third question here. So again, we have a right angle triangle, but this time we've been actually told the angle, okay? So again, we should immediately think we need to use trigonometry. So this approaches this as normal. So the side that's opposite the angle, that's going to be the opposite, right? Then the side that's opposite the right angle, and that's going to be the hypotenuse. And then the remaining side, well, that's going to be the adjacent, okay? Then, as normal, what we want to do is use SOH CAH TOA. So you write SOH CAH TOA down, and that will tell us what which equation we need to use. Do we need to use the sine equation, the cos equation, or the tan equation? So what we want to do is tick off the sides that we know, and also what we're trying to find out as part of the question. So we've been told the hypotenuse is 8 centimeters, so we can tick off h from SOH CAH TOA. Now, we've been asked to find length x. Now, you'll notice from our diagram that we've labelled x as the opposite. So what we can do using that information is tick off O. Okay, so we're trying to find the opposite. Okay. Now, the one that has the most ticks is the sine. So we need to use the sine equation to find the opposite. Alright. So what is the sine equation? So the sine equation is simply sine x is equal to opposite all over the hypotenuse. Okay, so very similar. All we have to do is just substitute the values in. So in this case, we know the angle, so it'll be sine 72 degrees. So the opposite, we don't know. Okay, so we'll call that x. So we're trying to find the opposite. Then hypotenuse, as we're told, is 8 centimeters long. So we'll put 8 down. Okay, put a degree symbol there. So all we have to do is rearrange this equation to figure it out. So x is 8 times sine 72. Okay, doc. Now, when you put this into the calculator, what you want to do is just double check that it's in degrees and not radians, alright? Then when you calculate this, you put this into the calculator, you get x is equal to 7.61 centimeters. Okay, doc. Now, does that seem along the right lines? Well, the hypotenuse is always going to be the longest side of the triangle. So we have the opposite as being 7.61 degrees with quite a steep angle. So that seems quite accurate, okay? So yeah, that is the process how to approach these questions. Just draw the triangle out, just label each side correctly with opposite, hypotenuse and adjacent. Then use SOH CAH TOA to identify which trig equation you need to use, alright? So the final exam question is a lot more problem solving based, okay? So in fact, if you're able to do this question, you'll be absolutely fine for trigonometry of right angled triangle questions in the exam, okay? This is a lot more complex, but what we'll do is we'll have a read through this question and you can see the typical strategy you'd use to approach this type of question. So what we have here is a square base pyramid. Now, the horizontal base, A, B, C, D, has side length, 10 centimeters, and center M. So I have A, B, C, D. So this is the base, and it's just simply a square, and it's 10 by 10, okay? So angle VMA is 90 degrees. That's a 90 degree symbol there. And we have angle VAM is 68 degrees, and that's this angle there, 68 degrees. So the question is to figure out the volume of the pyramid, alright? Now, luckily for this question, the equation to figure that out is given. So it's volume of pyramid is equal to 1/3 times the area of the base times the perpendicular height. Alright. So obviously the first thing that I would do when looking at this question is look at the equation and look at what I need to substitute into this equation to figure it out. So the first thing that I need to figure out is what is the area of the base, right? So if I look at this, the area of the base is so what we have is A, B, C, D, that's a base, and that's just a square, and luckily the lengths are given. So to find the area of the base, which is a square, is going to be length times breadth. So we can figure that out because the lengths are actually given to us. So it's just 10 by 10. So that gives us, so the area of the base is simply 100 centimeter squared. Alright. So that was the simple part of the question. We found the area of the base, alright, so we can tick that off. Now the hard part of this question is finding the perpendicular height. So if we look at this diagram, the perpendicular height is from point V down to point M. Okay, so we'll call that height, so you can see that more clearly. So how do we figure that out? Well, see if I look at this diagram, what I can immediately try to figure out is I can actually see a right angle triangle here, because there's a right angle symbol there, alright? So it's kind of hinting towards that direction anyway. So whenever I see a right angle triangle, I immediately think of Pythagoras. I might have to use trigonometry, or in fact I might actually have to use Pythagoras and trigonometry, okay? That's typically what you see in these more complex questions, alright? So what we can do is draw the triangle out, and you can figure out from there what we need to do further, whether it's going to be Pythagoras or whether it's going to be trigonometry or both, alright? So what we're starting off is point V, then we go down to point M, and then point A, okay? So what we have here is the angle 68 degrees and then the right angle symbol there. So I see a right angle triangle and I've got an angle 68 degrees, so that implies trigonometry somehow. So the first step is, what I would do is label the sides opposite, adjacent and hypotenuse, okay? So we're trying to find this side here, height, okay? So the side that's opposite the angle, that's going to be the opposite. Then the side that's opposite the right angle, that's going to be the hypotenuse. And then the last side is going to be the adjacent, just like that. Now the next step that we would typically do is use SOH CAH TOA, wouldn't we, to figure out what trig equation we need to use. SOH CAH TOA. So that of course stands for sine, then cos, and then tan. Alright, so at this stage what we do is we tick off the sides that we know, right, and we also tick off what we're trying to find out. We don't know any of these sides, no length is given, but the only thing we do know is that we're trying to find the height, which is V to M, and we've called that the opposite, okay, so we can tick off O here, right. Now this is a problem, we don't have enough information, because normally when we use SOH CAH TOA we're looking for 2 ticks at least, so we figure out what trig equation to use, but we don't know any other side. So this implies we need to do a bit more work to figure out what side we can another side of the triangle that we can sub in to figure out what trig equation we need to use. Okay, so what we have to do is look back at this diagram and try to find another side of this triangle. So what I can try to do is focus on this length here from point A to point M. Okay, the reason why I choose that is because that side looks like it has more information surrounding it. We have the base, which is 10 centimeters by 10 centimeters, alright? So I can work with that. That's sort of the mindset that I'm looking for, okay? So what I'll do is I'll draw the base out so we can see what we're working with. So we have just the base, which is a square, just like that. So we're starting off at point A, then we're going to point B, then point C, and then point D, and then in the middle we have point M, don't we? Okay, so if I find this distance here from A to M, that's going to be this part here of this triangle A to M, isn't it? Okay, so what we have here, we know it's 10 by 10, right? So I can split this square into another right angle triangle. Okay, if I extend that and I have a right angle symbol there, what we can see is we know the length of the sides. Okay, what I can actually do is Pythagoras, right? So if I find the length from A to C, then I can half that length, and then that tells me the length from A to M, okay, because it's at the midpoint, right? So to do Pythagoras, what we tend to do is the side opposite the right angle, well, that's going to be, we call that C, and then the other 2 sides is A and then B, okay? So I can do Pythagoras here to figure out from A to C. So what I'll do is, we'll do C squared is equal to A squared plus B squared. So we don't know what C squared, that's the hypotenuse. So A squared is just going to be 10 squared plus 10 squared. And then when we take the square root of both sides, we have 10 squared plus 10 squared. And then when we pop that into a calculator, what do we get? We get 14.14 centimeters. Okay, so that's the distance from A to C. Okay, now to find the distance from A to M, then it's just going to be the distance from A to C divided by 2. 14.14 divided by 2. Okay, so the distance from A to M is 14.14 divided by 2, which is 7.1 centimeters. Okay, so as you can see, that's where the extra bit of work is to find out the another side of this trig triangle. Okay, so it's just a bit more steps involved, but what we can do is sub in the distance from A to M into that triangle. So again, what I'll do is I'll draw the triangle here so you can see it a bit more clearly. There we go. So we have point V, then we have M, then we have A, then we have 68 degrees, then the right angle, and we're trying to find height. Okay, we're trying to find height. So of course this will be the opposite. This will be the hypotenuse. Then this side will be the adjacent. Now from this Pythagoras, what we found is the distance from A to C, right, as 14.14 centimetres. We've halved that to figure out the distance from A to M, okay, which is 7.1 centimetres. So that is going to be the distance from A to M is 7.1 centimetres. Okay, so what we can go do is go back to SOH CAH TOA to figure out what trig equation we can use. SOH CAH TOA. Okay, so sine and cos and then tan. Okay, so we know, what sides do we know? Well, we know the adjacent is 7.1 centimetres, so we can tick off A. And we're trying to find height, which we've called the opposite, so we can tick off O. Okay, now tan has 2 ticks, that implies that's the most with ticks, so we're going to use the tan equation. Okay, so that's the lengthy process that we've gone to figure out which equation we need to use. Okay, so what's the tan equation? So it's tan x is equal to opposite all over adjacent. Okay, so that will be, so what we have here is tan, so the angle is 68 degrees, and then the opposite is, we've called it height, right? So height, then all over the adjacent, and then the adjacent is 7.1 centimetres, and what we have to do is just rearrange this equation to find height. So height is equal to 7.1 times tan 68 degrees, so that gives us the height is equal to 7.1 centimetres multiplied by tan 68 gives us 17.6 centimetres. Okay, when you put that into a calculator. And there we have it. That's the final piece of information that we need to sub into the volume of the pyramid equation. Okay, so we found the area of the base, tick. Now we found the height, tick. Okay. Okay, so we're nearly there. Let's just do the final few steps. Okay, so the volume of the pyramid is equal to 1/3 multiplied by the area of the base multiplied by the height. Okay. So it's 1/3, so the area of a base is 100 centimetres squared, multiplied by the height, which we calculated to be 17.6 centimetres. So that gives us the volume of the pyramid is equal to 586.67 centimetre cubed. Okay, and there we have it. Yeah, so this was a lot of problem solving, definitely a difficult exam question to finish this tutorial on, but like I said, if you're able to comfortably do this question, then you'll be absolutely fine for any other right angle triangle questions in the exam. You just need to be able to remember the same process of labelling each side of the triangle correctly and using SOH CAH TOA. And of course you should expect to have to use Pythagoras and trigonometry in the more difficult questions. But hopefully this video has helped you, please do hit the like button and consider subscribing to the channel. And join me in my next video where we'll look at similar shapes. So I'll see you guys then.